Hi, welcome you all for this video on measurement of strain gauges through electrical strain gauges. In the last video, I had discussed about the mechanical type of strain gauge and optical type of strain gauges, and over the definition for basic definition for strain gauges. As you already know that the strain or the basic and important parameter of mechanical engineering, and strain is defined as the force applied per change in length per unit cross sectional area or original length, change in length per unit original length. Or if I am say volumetric strain, I have not we are not considering here. Let me restrict myself to the change basic definition of change in length to the original length. Where based on that the strain gauges are being designed. Based on that I am going to discuss here. Further, strain gauges are the devices which is used for measuring dimensional change on the surface of a structural member which is under test. Basically, the operation of strain gauges is simple and hence finds the large mechanical engineering applications. So now in this video I am focusing on the electrical type of strain gauges. Basically, these electrical strain gauges uh, in electrical strain gauges, a change in resistance strain produces the change in some electrical characteristics. It may be in terms of resistance, or it may be in terms basically, and that is being widely used. However, this electrical output can be magnified by some electronic equipments. The electrical methods of measuring strain possesses the advantage of high sensitivity and ability to respond to dynamic strains. That is the major advantage of these strain gauges. That is nothing but, in simple, these electrical strain gauges possess the potential to apply for dynamic characteristics or dynamic strain measurements, which is not possible with the help of mechanical strain gauges. The electrical strain gauges are classified according to a particular electrical property which is affected by the straining. As one is about capacitive transducers, gauges, inductance gauges, piezoelectric gauges, and resistance gauges. Basically, capacitance strain gauges represents the capacitors in which one plate of which is stationary, the other plate, which the mobile one, is connected to the workpiece under test. The deformation of the latter results in the capacitance change of the capacitor. The strain gauge serves as an element of a higher frequency generator, and the change in the strain gauge capacitance results in the change of the generator frequency. So, by the frequency change of the generator, it may be easy to judge the magnitude of the deformation in the place where the gauge is fixed. Whereas in the inductance strain gauges, the gauges are in fact of coils with a mobile iron core. The core or the coil is connected to the workpiece to be tested. The deformation, the core either moves in or out, because of which the inductance changing accordingly. Tensometers with electrical strain gauges have a great advantage over any other kind of tensometers. They provide distance reading practically at any distance from the object under the test. However, apart from advantages, both conductive and inductive and capacitive gauges also have number of drawbacks. Like example, capacitive strain gauges are very sensitive to vibrations, and it is very difficult to fix them to the workpiece which is to be tested, and it may be quite impossible to test the piece whose configuration is complicated. Inductive strain gauges have some disadvantages, and besides, they have much greater weight and size. Piezoelectric strain gauges. These are the active devices. The strain sensing material is generally barium titanate. When compared to piezoelectric transducers that use quartz as a sensing material, the strain gauge provides an electric charge on its surface, which is proportional to strain and that can be measured with charge amplifiers. Those are all about the other types. Now let us go with the first focus on the electrical resistance strain gauges, which is of interest in this video. In electrical resistance strain gauges, the displacement or strain is measured as a function of resistance change produced by the displacement in the gauge circuit. These are a common and widely used type of strain measuring devices among electrical strain gauges. In operation, it is based on the principle, as I mentioned, the resistance relationship with the change in the displacement. Typically, an electrical conductor is being stretched, its length will increase and area of cross section will decrease. This results in the change in the resistance, and change in the resistance per unit strain we call it as a are defined as a gauge factor. About this gauge factor in detail I will discuss in the next video. Here it indicates, simply we can remember that gauge factor, it indicates the sensitivity of the strain gauges. Typically, an electric conductor is bonded to the specimen with an insulating cement under no load conditions. A load is then applied which produces a deformation in both the specimen and the resistance element. This deformation is indicated through a measurement of the change in resistance of an element. Like example, resistance of a conductor R is given by R is equal to rho into L by A, where L is the length of the electrical conductor, A is the cross-sectional area of the conductor, rho is the resistivity of the conductive material. In other words, when a conductor is stretched, its length L will increase, area will decrease, and the resistance will increase. Similarly, when the conductor is compressed, resistance R will decrease, and obviously when the conductor is resistance is decreased, correspondingly Strain can be measured in calibrated to the change in the resistance. So finally, these electrical strain gauges with the metallic sensing element may be broadly classified into four categories: unbonded type of strain gauges, bonded type of strain gauges, foil strain gauges. In the bonded type strain gauges, foil type of strain gauge and wire type of strain gauges, whereas the next one is weldable strain gauges. Fourth one type is semiconductor or piezoelectric strain gauges. The unbonded type, this is the first type of strain gauges. Unbonded wire type strain gauges. In an unbonded type of strain gauges, the grid is supported, whereas a fine wire is stretched out between the two or more points, which may form part of the rigid base, which is strained as shown in the figure. Movements of point A and B causes tensile strain in the resistance wire, and the change in its resistance is measured by a suitable circuit to give a signal, which is a function of strain. Generally, four separate filaments are connected electrically to form the Wheatstone bridge and are arranged mechanically. So in that, filaments in the adjacent bridge are subjected to strains of the opposite sign, as we can see in the figure here. So the resistance filaments under the tensions are wrapped around electrically insulated pins. Please connect yourself to the figure so that what I am explaining you are getting you can understand from those points in from the figure. So the resistance filaments under tension are wrapped or electrically wound insulated pins. When movable platform is moved relative to the fixed base, filament tension are either increased or decreased, and corresponding resistance change may be calibrated in terms of strain. The assembly must provide a bulk in pre-strain in the grids greater than the maximum compressive strain to be sensed. The major advantages are like because of its radial symmetry, spurious transfer forces are cancelled. Very low hysteresis and creep based unbonded type strain gauges. Force summing and force sensing components can be integrated here. Disadvantages are being like problems of fixing at the place of this measurement. Applications: these unbonded type of wire strain gauges can be used in uh, displacement transducer, placement transducer, and acceleration, or nothing but the accelerometers. Further, bonded type resistance strain gauges is a suitably shaped piece of resistance metal which is bonded close to the surface whose strain is to be measured. Generally, it is a thin wire shaped which is cemented into a grind pattern, which is cemented between thin sheets of insulating material such as paper or a plastic, so that the grid can also be made from thin metal foil. The assembled gauge is bonded to the surface with a thin layer of adhesive and finally waterproofed with a layer of wax or lacquer. The grid experiences the same strain as the material to which it is being bonded. The gauge is most sensitive to the strain along its axial direction XX, while the strain in the y direction YY occurs due to the Poisson's ratio effect. These gauges change of resistance and may lead to the error of about 2% in the measured strain when using the wire bonded gauges. However, in the foil gauges, the thickened end reduces the cross sensitivity effect to a virtually zero. The displacement, if the however, in the foil gauges, the thickened end reduces its cross sensitivity effect to virtually zero. If the direction of principal strain is not known, then the cluster of 3 or more strain gauges are used, which are called Rosettes. In the wire type strain gauges, it consists of a very fine wire of diameter 0.025 mm wounded into a grid shape, as you can see it in the figure, and the grid is cemented between the two pieces of thin paper with plastic or ceramic backing. This is done in order that the grid of the wire may be easily handled. This is securely bonded with a suitable cement to the surface of the member in which strain has to be measured. In the foil type of strain gauges, it has a foil grid made of thin strains, sensitive foil. The width of the foil is very large as compared to the thickness of microns, so that the larger area of the gauge is available for cementing. Weldable strain gauges. These are the easy to install in minutes and in any environment compared to bonded type of strain gauges. The weldable strain gauges consists of a strain sensitive element. The nickel chromium or platinum tungsten are housed within a small diameter steel tubes. The strain element is insulated from the tube with a highly compacted ceramic insulation. The this kind of gauge is subsequently spot welded to structures under test and provides the bonding to transfer the strain. However, the test specimen which is put into tension or compression, the stress transmitted through the weld to mounting flange through the weld to mounting flange and into the strain tube. So these gauges which can be used for static and dynamic applications, which was the major drawback of The mechanical and optical strain gauge. For the semiconductor or photosensitive strain gauges, unlike other strain gauges, semiconductor strain gauges are based upon the piezoresistive effects of silicon or germanium and measure the change in resistance with the stress as opposed to strain. The semiconductor bond strain gauge is a wafer with the resistive element diffused into a substrate of silicon. No backing is provided for the wafer elements and bonding is to be strained. Surface needs extra care since only a thin layer of epoxy is attached to it. Size of the strain gauges semiconductor type is much smaller and the cost is also much lower than that of a metallic foil sensors. The major advantages of electrical strain gauges are like they are very high gauge factors and also available positive and negative strain gauges. Next one is about its very compact size. That's why just like a tape it is being used or pasted over the surface for which it is to be tested. Chemically inert, that is the most another important characteristic of the instruments, measuring instruments. Hysteresis and creep effects are completely absent here. Better fatigue life or and better sensitivity. Applications in transducers where the high sensitivity is required, especially the transducers with high sensitivity applications are required, then generally this kind of strain gauges can be utilized. Through this video I have tried to give an insight about the electrical type of strain gauges which are of various types. I hope the working principle of electrical type strain gauges are clear to everyone, and if you have got any doubt please post it here or mail it to my email ID. I will try to answer those queries. I have used preparing the staging material like videos or the content material from the I have used many I thank to all for watching this video. I have tried to give insight into the electrical type of strain gauges through this video. I hope it is clear. And I have used many textbooks and internet resources in preparing this teaching material. I acknowledge all such sources and don't claim any kind of novelty in this. I thanks to all those sources and others who have helped me in preparing this video. I also thank you all for watching this video. So thank you. We'll meet you with the next video. In the next video, I'll be discussing on the preparation and mounting of strain gauges. So thank you all.